Okay, so this came up in the last video, but I wanted to kind of hit it harder here. This idea of the multiplicity of solutions. And it goes back, one way to think about it, it goes back to the unit circle. If I'm asking about sine of this angle equals 0.72. So I need to know when this angle, when I take the sine of it, gives me 0.72. One way to think about that is the y value on the unit circle needs to be 0.72. This is a y value of 0, right? Because this is 1, 0 out here. And when we get up to this point, it's 0, 1. So this 0.72 is somewhere between 0 and 1, closer to 1 than 0. So let me say 0.72 is like here, right? And as I draw this line across, I can see that that's going to happen at two places on the unit circle, here and here. And we established that if this angle is theta, that means that this angle is theta, and that means that this other angle measured from the reference line here is 180 minus theta. So we have this fact: sine theta is equal to sine of 180 minus theta. Now, of course, there are more solutions because I can go, we've got two solutions so far. We can get more solutions, right? This is sine of theta equals sine of theta plus 360, right? Because adding 360 degrees to the angle gets me back to the exact same spot. And then I can take 180 minus theta and add 360 and get more answers there too. But I'm not going to write that one down. I mean, basically, this is one way to get a new answer. This is another way to get a new answer. And I can add 360s until the cows come home to get more answers from any of these two numbers. So let's just do this one in particular. If sine theta equals 0.72, then theta equals inverse sine, which is 46.1, rounded to the nearest tenth place. And so then 180 minus theta gives me my second solution. $133.9. Excuse me. And we can go on from there. I can add 360 here. I can add 360 here. I can get more and more solutions. Now, typically, as we kind of gravitate towards solving equations, we'll think about theta not in terms of degrees, but in terms of radians. So let me do another example with cosine, and this time we'll talk about it in terms of radians. So make sure you switch your calculator over to radian mode. And let's say cosine theta equals negative 0.6. Okay, so let's think about what this means. Cosine theta is negative 0.6. Well, cosine is the x value, right? X, y. So we're talking about negative x values over here. Negative 0.6, if this is 0 for x and this is negative 1, negative 0.6 is going to be somewhere along this kind of neighborhood. And so I've got 2 points where that would happen, here and here. So I've got my first theta, and then I've got my second solution. And generally, the easiest way to think about that answer is it's minus theta. So in other words, if I go the positive direction, I get to have cosine theta equals negative 0.6. But if I go the other direction, negative theta, then I'll also need a place, and it'll be a different point. Now, if I want to talk about it in terms of a positive angle, it's just 360 minus theta. So we have this fact. The cosine of 360 minus theta is equal to the cosine of theta. So let's take a look in terms of radians. Let me switch my calculator over. Okay, so now I'm going to say, what is the inverse cosine of negative 0.6? Find out. 2.214. Okay, I freaked out for a second and then I reminded myself, oh no, we're in radians. This makes sense. Remember that pi radians is half a revolution. So this is pi over here. What is pi? Well, it's about 3.14. So does it make sense that this is about 2.2 radians? Yeah, that makes sense. It's, you know, getting close to 3, but it's not quite 2.3. So this is a sensible answer. So the other solution then would be not 360 minus this, but 2 pi minus this. Okay, so let's see what that is. 2 pi minus 2.214. I got a pi button on my calculator, 4.069. So now I have two solutions, theta 1, 2.214, theta 2, 4.069, and I can have as many solutions as I want. All I have to do is keep adding 2 pi's. Now, when we get to solving trig equations, we'll add 2 pi n as a way of kind of generally solving the equation. But, you know, just for right now, I just want to kind of hit the fact that we got multiple solutions and how do we find the second, third, fourth solution, however many we're asked to find. All right, onwards and upwards.